Good morning, everyone. Thank you for joining. Welcome to Steam Management Showcase webinar series. We are excited for our presentation today on mastering Steam systems. Common challenges, troubleshooting tips, and maintenance best practices presented by our guest speaker, Ray Wolfarth. Ray will share his extensive experience addressing issues in Steam systems and also convey why Steam is still a practical medium today. This is a crucial presentation for energy stakeholders who desire to know more about Steam systems. Yeah, you could go back one. Thanks, Ray. We are Steam Management. We specialize in developing and implementing turnkey retrofit projects focused on optimizing Steam and other utility systems for efficiency improvement. Our solutions are designed to significantly reduce energy costs, conserve water, and decrease carbon footprint for our clients through a holistic and thoughtful approach to each system's optimization strategy. We serve various markets nationwide, and we are committed to delivering tailored solutions that meet operational and sustainability goals. Next slide, please. I'm Chase Bean, your host and Steam Management's VP of Engineering and Revenue. I'll be asking and moderating questions throughout the presentation. We do encourage active participation, so feel free to ask questions and share insights in the chat section, and I will point those out to Ray as they come up. Also note that this is a technical presentation. We do offer PDH certificates for ongoing education for anyone that has PEs or CEMs or anything else where you can use those certificates. So the normal process for that is to email me there at cbean@steammgt.com and request that after the presentation. Also note that our existing and our past webinars are available at steammgt.com/webinars. Next slide, please. Our featured speaker today is Ray Wolfarth. He's the president of Fire and Ice Heating and Cooling in Pittsburgh, Pennsylvania. He is an international author of 17 books with a focus on boilers. Ray has contributed articles to numerous industry publications and maintains a popular YouTube channel, Boiler Room Detective, with over 120 troubleshooting videos. Ray also serves on the boards of the West Virginia ASHRAE and West Virginia APA, and has taught boiler classes for leading organizations including ASHRAE, RSES, Hospital Engineers, National Association of Power Engineers, Operating Engineers, Steam Fitters, Building Owners and Managers Association, International Facility Management Association, and the Association of Physical Plant Administrators, as well as HeatSpring. I personally have found Ray's books and content very useful. We are very grateful that he is presenting with us today. Ray's books are available on Amazon, and he just released a new book called Lessons Learned Troubleshooting Hydronic Heat that you should definitely check out. I have it on my desk right now most of the way through it. It's very interesting. And also be sure to watch and subscribe to his YouTube channel, which we will have a link for at the end of the presentation. So without further ado, I will hand it over to Ray and we can get started.
Good morning, everybody. Like Chase said, I'm a author of different boiler books and columnist. And it breaks down to I'm a boilerholic. And you're thinking, what is a boilerholic? Well, when I first found out I was a boilerholic, I was watching this iconic movie with Arnold Schwarzenegger and Chainmail Guy there. And in the movie, they have green steam coming out everywhere. And I'm thinking, wow, green steam. And then at the end of the movie, Arnold rips a pipe off the side of the wall, off the side of the boiler, throws it right through Chainmail's stomach. And you see this wisp of steam coming out. And Arnold says, I'll be back. Or he says, let off some steam, Bennett. And right then and there, I thought, oh, that's wrong. Who's servicing these boilers? This is horrible. So it's an affliction I have. And I'm fascinated with boilers, and I hope you are, and have fun with me along the way. When I talk to people, and they ask about steam. Steam seems to be something that they're confused about. But I have this theory that you already know how to troubleshoot steam. You just didn't know you knew. And we're going to go through some of it this morning. Are boilers extinct? Now, don't laugh at me, but I had all three of these items that were up here at one time. Now, I didn't have the Pacer. It was my brother, and I drove in it grudgingly. boilers are used, they touch every aspect of your life. They're used in all kinds of different facilities and and they used to be in every building that was heated. But most importantly, I think the biggest bonus for steam boilers is it makes beer. How could it be bad then, right? It's got to be a good thing. Now I hear one of the people say, "Oh, steam is not efficient." People will tell me that all the time, and I say, "Well, let's look at the Empire State Building in New York City. It's 102 stories high, 1,250 feet high. It heats the building on 2 to 3 pounds of steam. It won a LEED Gold award for efficiency." And people are like, "Well, how could that be? That's impossible." Well, steam zooms through a building at speeds of about 50 to 60 miles per hour without using a fan, a compressor, or a pump. It works on steam pressure. And typically, if you're designing a system, for every 100 feet of piping, you'll lose about 2 ounces of steam pressure. Another thing is, you think about steam or hydronics, water transfers heat 3,500 times better than air. Steam zooms through, like I said, at 50 miles per hour, 50 to 60, without a compressor, pump, or blower. A 1 inch pipe can carry as many BTUs as a 20-inch round duct. Now, people here say, "Oh, boilers are dangerous." Well, they used to be. They used to be very dangerous. Between 1879 and 1891, in that short 12-year period, 2,139 boiler accidents in the United States, one every 48 hours. There was over 3,000 people killed, 4,000 people injured. And residential steam systems at that time operated at 60 psi. And they didn't have the operating controls and safety controls we have now. So at one time, they were very dangerous. I found this on a copper fin boiler site, and they have since taken it down. And the engineer that was doing it was trying to show how their boiler was so much safer than anyone else's. And he had the horizontal water tube in the middle, and he said, if the cast iron sectional blows up, it's like equivalent to 32 pounds of dynamite. And if the horizontal water tube blows up, it's 63 pounds of dynamite. He said, if ours blows up, it's only 10 pounds of dynamite. Well, I don't know about you, but I don't want to be in a room with an ounce of dynamite. But they have since taken it down, but I kept it for so I can use it in my seminars. But steam boilers can be dangerous. In this St. Louis explosion in 2017, 4 people were killed. And it wasn't in this building here, wasn't the one where the steam boiler blew. The 2,000-pound piece of equipment was here in the right at the box company. It traveled 520 feet away at 120 miles an hour. It was 425 feet high, and it was airborne for 10 seconds. It landed in this healthcare linen place, and 4 people were killed because that a piece of the boiler flowed down or fell down on them. And then I hear people say, "Well, boilers are still dangerous." Well, let me put it into context for you. 500 people die a year from hippos. 150 people die a year from falling coconuts. 100 people die from falling icicles. And 13 people die from shaking a vending machine. Less than 10 people die from boilers a year. And I'm thinking to myself, you're 30% more likely to die from shaking a vending machine. And I always wonder, what would it be like for the person that died that way to go up to the pearly gates and they're comparing notes on how they died. And one said, "Oh, I was hit by the coconut." One was, "I was run over by a hippo." And then they come to the person that had the vending machine fall on them. I think they would put them on a little special couch and say, "Don't talk to anyone else while you're here." So the good thing about boiler accidents is most of them can be avoided by simply doing maintenance. Um, these are the reasons they give they used to categorize them this way years ago of what causes boiler accidents. And poor maintenance was the number one thing, followed by low water cutoffs, limit controls, burner failure, relief valve. I don't know what unknown is. That's probably someone thinking that they were supposed to do something and they did something dumb. But most of your boiler accidents can be resolved by simply doing maintenance.
Ray,
That's why I love it.
sorry to interrupt, what maintenance activity do you think is the most crucial for avoiding an accident? There's a lot of maintenance activities going on, but what do you think is neglected the most that could cause an accident?
Well, I think the boiler or the low water cutoff, that's the leading mechanical cause of boiler failures. And it should be checked and it should be opened up and looked at and inspected yearly. People just don't do it anymore.
Yeah. Okay. Great. I totally agree with that.
Um, ASME CSD1 is in about 40 different states. It's a great code. And I tell this to all the, if there's mechanical contractors or service contractors here, I tell the people if your state adheres to this, excuse me, you should get a copy of the code and give it to every one of your service technicians because what it does is these are boilers, ASME code CSD1 handles boilers up to 12,500,000 BTUs. But it says the owner or user of an automatic boiler system shall develop and maintain a formal system of periodic maintenance and testing. Any defects found shall be brought to the attention of the boiler owner and shall be corrected immediately. Now, what that does is that lets your service technicians off the hook because they say, hey, this thing needs to be done. And if you present the code to the owner, it's not you telling them it has to be done, it's the code saying it. So it makes it easier. Sometimes technicians get a little intimidated by building owners. Now, when we were in grade school or elementary school, we used to hear all these stories about Mark Twain in the riverboats. And I kind of thought, well, that's kind of dumb. Why would they even talk about that? Like, he had such reverence and respect for them. Well, what I came to find out was it was a 50-50 chance of a boiler blowing up when you were on a riverboat in Mark Twain's time. So it was an adrenaline rush to him. When he got off the boat and if the boiler didn't blow up, he's like, yeah, we made it. And so back then they didn't, everything was done by hand. You didn't have all these automatic controls. Who does the maintenance? I'd love to find a guy that did this. This has to be like in the Guinness Book of World Records for how many uh, straps you can put on the one pipe. I have people that'll say, well, we don't do maintenance. There was a hospital I was talking with that says, I don't do maintenance. He said, we have insurance. And I said, well, do you mind if I read over what's not covered? So I went through this and I'm going to read it really quickly. And then at the end of it, I'd love to hear your thoughts on what's covered. Depletion, deterioration, corrosion of material, erosion of material, wear and tear, leakage of any valve fitting, shaft seal, gland packing, joint or connection, breakdown of any vacuum tube, gas tube, or brush, breakdown of any electronic computer, electronic data processing equipment, the breakdown of any structure or foundation supporting the object or any part thereof, an explosion of unconsumed fuel within furnace of any object or within passages from the furnace of said object to the atmosphere, the functioning of any safety device or protective device. What's covered under this policy? Nothing. And when do you typically find out what's covered under someone's insurance policy, before or after an accident? And it's usually after the accident. So when a person says we don't have to do maintenance, we have insurance, ask to see their policy. Let's look around the building for what we see that could be dangerous there. Is the room safe? In the one on the left here, the boiler was behind all this crap that was in front of it. And I asked the owner, I said, well, how do I get to it? He said, well, just climb up this ladder and the boiler's over there. And I'm like, nope, not going to do that. And he said, oh, the other guy did. I said, I don't care. And then I saw the cross that he put on the radiator. I'm thinking he probably put that on there like in case something happened, look back here for me. The other thing, this is my church, and they never listen to me, right? I said, whatever you do, don't put gas powered or gasoline inside where the boilers are. The reason being is that gasoline fumes are heavier than air, and they'll go right along the floor and then get sucked into the boiler and cause it to catch fire. So look around the boiler room, make sure it's safe inside there. Weil McLean has this listed of all the things they don't want in a boiler room because they could have an adverse effect on the flame and cause corrosion and destruction of the boiler. And I would hazard a guess that two or three of these are probably in every boiler room you have. Calcium chloride for snow melt, sodium chloride for water softening, and I don't know how many times you're going to have permanent wave solutions, but hey, uh, is there an emergency door switch? These are part of the ASME CSD1 code, and these are awesome. I mean, I recommend these highly. If your boiler doesn't have it, I would urge you to get them in there. I'll give you an example why it's so important. The boiler on the right, you can see the crack sections here. Well, what happened in the middle of the night? The smoke alarm went off inside the boiler room. The fire department came, and the fire department used their infrared cameras to find out what is the source of the flame, or the heat. So they found the source of the heat, and the steam leak was this boiler here. So what they did was they trained their hoses on this boiler, and it cracked every section in the boiler. And they're lucky it didn't explode and take half the building with it. But it cracked every section, and the ones that aren't cracked on this side, they were cracked on the other side. But all of this could have been avoided if the fire department had come in, found the switch, hit the button, let everything cool down, and figure out what's going on. As a result, it was about a $60,000 or $80,000 repair to replace this boiler, plus the dangers that was incurred. Always check the wiring connections on the burner in the boiler. They loosen up after a while, and we check them twice a year when we're out on the job. And you can see this one, it's a little bit tough to see. It completely melted the terminal where L1 was coming in. And we ended up having to change it over. And this was only a boiler that was only a couple of years old. And it was because the screws down here holding the wires in place were not tightened. Look for sagging pipes inside the boiler room. Where if the hanger came loose, or if there's just naturally dropping down, um, what that does is that allows water to pool inside here. When steam hits this water, it causes a phenomenon known as condensate-induced water hammer. And I'll show you, these are two of them. This Kirshner.org is experts in this, and these are from their website. It can generate pressures as high as 1,500 psi. What it causes is let me go back here, is when the steam hits this, it causes the steam to collapse prematurely, and it actually pulls it into a vacuum and sucks it in. I'll show you an example of that right here. You can see this. That's exactly what happens inside a pipe with condensate-induced water hammer. Your pipe is designed not to burst outward, but inward, it sucks it right in just like this. I told you I'm a boilerholic. I collect this stuff. This is crazy. But anyway, it's scary. Is there carbon monoxide in the boiler room? Carbon monoxide is very dangerous. We What happens is carbon monoxide displaces the oxygen in your blood's hemoglobin, and it forms what's called carboxyhemoglobin. And the troubling part of it is that it has a 5 hour half-life. So say we were exposed to 500 parts per million and we pulled you out of that building and we put you into fresh air. It would take 5 hours for the carbon monoxide level in your blood to drop to half that amount. After another 5 hours, it would drop in half again. So your body really prefers carbon monoxide to oxygen. And so you want to be able to make sure you're safe when you walk inside there. Is this a good Friday afternoon project? I would not touch this. So if you see something like this is a Monday project. I'm just going to tell you because what will happen as soon as you touch this, everything's going to fall apart and you're going to be scrambling all over town trying to find the repair parts to do this. The low water cutoff is the leading mechanical cause of boiler accidents. The one on the left, you can see all the mud that's up in here. And this float was just hanging on the mud, and the boiler dry fired. It thought it was full of water, but it was actually the low water cutoff was full of mud. Now, this one, a friend of mine installed in a church in West Virginia. He sent me this picture on a Saturday night. This boiler was only about 9 months old. They had just replaced the boiler before the dry fired, and they never blew down the system or anything. So the insurance company paid for the first, and they told the owner they were only going to pay for half of the second because they did no maintenance on it. And the owner says, "Oh, we blow that down every week." Well, you could see all the crap up in there. There was no way they blew this down. And the one on the right, a friend of mine sent to me, this was a low water cutoff, and you could see it was filled with sludge and mud. There was no way it was going to operate up and down. Now, the float inside a low water cutoff looks like something inside the toilet bowl at your on your toilet. So it's a little float that's going to go up and down. That's just what this is here. Inside the McDonnell Miller 150, these are really common on steam boilers, and we see them. And what this has is two switches. This switch over here, the closest or to the bottom, is what is the low water cutoff. This goes in series with all of your low water cutoff or all your safety controls, like the operating control, your limit control. The one on here is what brings on your feed water pump or your boiler feed system. Now you'll notice that there's some wax that they put on these. That's meant you're not supposed to touch these. I've had service technicians that will remove that and try to adjust this up or down, and it doesn't really, it puts you in responsibility for this, and you don't want that to happen. What I tell people when I'm talking to service technicians or installers, what I'd love to see are plug or the caps and nipples on the end of the piping going into your low water cutoff. If you have plugs on here, if this side's going to be exposed to steam, this one's going to be down here lower, it's going to be in hot water. These things will run off. It's really tough to get these out. So if you have a cap and nipples, it's a whole lot easier to remove this. These have to be opened up every year. This is what senses the water level inside your boiler. This has to be removed. All these caps have to be removed, and this has to be cleaned to make sure it's not plugged so the boiler doesn't dry fire. Top safety valves. This one in the center was from an explosion of a boiler, a cast iron boiler that blew up. And a friend of mine that was responsible, he was a boiler inspector, sent this to me. And you could see why it failed. This is the last line of defense, and someone decided to install a valve on there and it was closed. Uh, this is my favorite on the left. the owner was like, "There's no way this is going to leak again. I'm putting a valve on here and a cap." It just makes me laugh. Uh, and then the one on the right is something we see all the time. We On one job we sold a boiler to the installer, and he put it in, and it was a 2-inch outlet on the pop safety valve. And when I got to the job to do the startup, they had a bushing put in there, and it was dropped down to 3/4 inch. Well, what that does, that reduces the relieving capacity of that valve. So when I asked the installer, I said, "Hey, you reduced that." He said, "Well, I didn't have any 2-inch." He said, "But I had all kinds of 3/4 inch." And that's how he rationalized it to himself. And if you see this on a job site, this has to be removed and replaced with the same pipe diameter or even bigger.
Ray, I remember reading about one of the first major locomotive explosions, the stoker, which is what they used to call the guy that shoveled coal into the boiler. He was annoyed that the safety relief valve was whistling, and so he shoved a rag in it,
Oh my
and
goodness.
it caused the boiler to explode. So. But yeah, I no restrictions anywhere in the safety relief, as well as the low water cutoff that you were showing that you
Right.
can't put any valves on that either.
No. Oh, you can. You're allowed. I mean, you're not allowed to do it, but this is America, and you can do whatever the hell you want sometimes. You're entitled to be do dumb things. The pop safety valves. When I'm doing my classes, and if you were here in front of me, I'd be looking around the class. I'll say, "How often do you test your pop safety valves?" And nobody wants to make eye contact with me because nobody does it. And I'll ask the group, I'll say, "Well, why don't you do it?" And everyone's response is the same. "If I test it, it will leak." So you never want to do it on a Friday. These are always a Monday morning job, so you can find a pop safety valve. So how often should you test it? Watts, who recommends once a year. Combraco, which is Apollo, recommends twice a year. And Kunkel says safety relief valves should be operated only often enough to assure that they are in good working order. I have no idea what that means. And I don't think it was an engineer that wrote that. I think it was a lawyer that said, "Okay, we're going to put this on there and this should take care of it." One of the other things that the technicians also forget about is that to properly test a pop safety or relief valve, they want you to take it at 75% of the rated capacity. And what they are saying is that if it's a 15 psi relief valve on a low pressure steam boiler, you have to take it up to 11 psi, test it, and then drop it down to whatever pressure you're operating it at. One of the things I don't have on here is there's a pressure margin that a lot of these pop safety relief valve manufacturers will say on there. And we're running into issues with breweries because they try to run your low pressure steam boilers at 15 psi. And Combraco and the other ones will say we need a 4 to 5 pound margin in there, which means they don't want you running your boiler higher than 11 to 12 psi because it could ruin the pop safety valve. Can the
Hey Ray,
boiler
there's a
breathe?
question in the Q&A. Is there any danger of insulating the low water cutoff with removable jacketing?
No.
I missed this question a few minutes ago. Sorry.
Yeah, no, no, you can do that because they do get pretty hot.
Okay.
I'll get going. Can the boiler breathe? This is common. We see that they'll have louvers in the wall or the doors, and it gets so cold inside the boiler room that in this particular one, it was a school district, and the teachers would go in there to smoke cigarettes because it was the only place they could smoke. So they had the custodian put this uh, piece of wood up there to try to reduce some of the cold air coming in. Well, what it does is now your boiler can't breathe. You're going to start going into a lean uh, operating condition, and your boiler's going to soot. Look for leaks. Do you see steam coming out? If you do, get them fixed. It'll destroy your boiler and piping pretty quickly. If I see this was a relief valve that was on a school that we were looking to consult on, and I saw all the steam coming out of here. And I told the guy, I said, that's money. That's money you're losing, plus all the equipment you're destroying. And you're like, oh, we don't have money to fix it. I said, this thing will pay for itself. So typically, if I see the vent pipe coming off of a boiler feed tank and throwing that much steam on, it's telling me the steam traps are blowing through and you need to have them fixed.
And yeah, if you think about the steam leaks, they're all coming through when they first form. They're coming through at choked flow, so it's as high a velocity as could possibly go through there with the
Yep, yep.
pressure, and so they erode the pipe even further. So it quickly makes the situation worse. That's why the safety relief valves leak, like you were saying. They erode the seal there. But while I'm already interrupted, we did have a question. Any recommendations on condensate and feed water quality? So you can address that now, or if you talk more about that later, you can address it,
Um,
but just wanted to point that out.
what I would do is I would talk with your boiler manufacturer, what they recommend, because it's going to be different for each one. Um, and just to use some sort of an off the cuff thing, I mean, there's some, I don't have them in front of me right now, but what I typically do is I'll pull up the manual for the boiler and I'll show them that this is what they want to do. One of the things I can't urge this enough is if you're going to do water treatment, which is recommended for any boiler, make sure you find someone that knows boilers. We had a guy in West Virginia at this university, and he bought water treatment chemicals from the guy that sold him his cleaning chemicals. And he talked them into buying this descaler for inside the boiler. And they said, oh, this will make your boilers just like new. Well, they put this descaler in, and within about a month, they had leaks everywhere. It was like a sprinkler system. Um, and the descaler did its job and it pulled the scale off, and the scale was the only thing holding the piping together. They had to replace all the boilers in the one building, and they had to replace almost a mile of pipe. So make sure you find someone that knows boilers, if I can say that. Um, when you're looking at the gauge glass, you could see where the red arrow is. That's oil on top of here. Now, oil will drive you crazy. It will cause bouncing water conditions, carryover. Um, it will end up going off on low water. And typically, where the oil comes from is if they've had some piping done on the boiler, and that's cutting oil. Or if it's a brand new boiler, it was the oil they used at the factory when they were machining the equipment. If you see oil, make sure you clean out. Now, one of the things that I'm going to caution you on is I've had boiler maintenance people drain down the boiler and then refill it with fresh water, right? Well, that oil adheres to all the metal sides on the water side of the boiler. So when you bring that water back in, it bounces right to the top of the water level and says, hey, I'm back. So you want to be able to have something that's going to clean that oil. Uh, and then what I would do is check with the boiler manufacturer for what they recommend. How can you tell if the gauge glass is empty or full? One of the tricks I learned from Dan Holohan, who's like the boiler expert, uh, is I'll hold a pencil behind the gauge glass. If you see on the left, it almost looks like that pencil's intact. That's telling me that the gauge glass is empty. If you look on the right, you'll see it looks like it's broken on a 45-degree angle. What that's telling me is that there's water in there. So if you hold a simple pencil or something up behind you, if it looks broken, it's flooded. If it looks like it's pretty much straight through, it's empty. Are the radiators covered? We have people that will cover them and they'll say, "Oh, you know what? We want to, it was ugly. Those things are ugly." And but what happens is it really reduces the heat output of that. If you look at this and I would ask you, I'd say, "What is this?" And you'd say, "Well, it's a cast iron radiator." Well, is it really? I mean, technically it's called that, but the heat output from this thing is 60% convection and only 40% radiation. So when you go back and you put that cover on here, we've lost the convection ability of my radiator. So now what's happening is I'm only getting the 40% radiation. I'm losing 60% of the convection out of the heat output of there. Always assume the boiler was installed wrong. I can't believe the guy walked away from this and go, "Yep, we're all done on that job." So, um, one of the things I wanted to talk about, steam works opposite of what you think. So if you're working on a
Hey,
steam
Ray.
system, yes.
Sorry to interrupt. I got another question here. Building is heating differently at different areas of the building. Tried bleeding the system and it helped a little. Anything you recommend? What could be the problem?
Sounds like it's a
Uh,
hydronic system. You could probably reduce some of the flow to the areas that are overheating. Um, and then that'll force more water into the areas that aren't heating. Or you can make sure there's no air in the system. If you bled it, there is no air then.
okay.
I hope
All right.
that
Thanks.
helps. Steam works opposite of what you think. So if you're in a steam system, you got to throw away all your HVAC expertise and your hydronic expertise because it goes opposite of everything you're thinking of. Steam, when water turns to steam, it expands at 1,600 times its volume. To put this into perspective, we have a 16-ounce bottle of Aquafina. If we were to turn it into steam, it would fill 100 feet of 2-inch pipe. Condensate temperature is about 10 to 20 degrees below the steam temperature. So if you know what kind of steam pressure you're running, if you're running it at this at 219 degrees, the condensate temperature is going to be about 10 to 20 degrees below that. The higher the pressure, the slower the steam, right? It goes against everything we're saying. We want steam to get there faster. You think, well, I'm going to increase that steam pressure. All that does is slow it down. Compare velocity. Say we have 100 psi steam pressure. The velocity of the steam in a 2.5-inch pipe at 300 pounds per hour will be almost 10 feet per second. If we lowered that down to 15 feet per hour, the speed increases up to almost 35 feet per second. So it's substantial. So the idea is you want to, on a steam system, you want to keep the pressure as low as you can, um, so it'll get to the system faster. But there's going to be an issue. We had a hospital here that had someone come in and they had their system on the left and everything was set for 100 psi and they had the limit at 150. And they said, "Hey, we have this great idea. We only need 100 psi when the laundry is running. When the laundry's not running, we don't need that much." So they put in a complete set of modulating controls and operating controls. So when the laundry shut down at 3 o'clock, they switched it over and these were in here. Now, what happened is as soon as they did that, they started noticing all kinds of carryover, bouncing water levels in the boiler. Um, it was going off on low water. Well, what caused that? Well, remember when I talked about the lower the pressure, the faster the steam. It was going so fast, it was pulling the water out of the steam because the velocity of the steam was so fast. They ended up having to take it back up to the 100 psi, and because they couldn't keep the boiler running, it would kept going off and tripping on low water. And
Hey Ray,
what's
we
weird
see
about
that we see that reduction in steam pressure a lot as a an efficiency opportunity. Oftentimes it'll just be a section of the system, like we'll do a digital PRV or something like that. Can you talk about how you would evaluate being able to turn down a boiler, or what you would
well,
how you would approach that?
yeah, I mean it's a great idea. You're going to save money with it, but you have to make sure you factor in the velocity. What I tell people to do before you implement something like this is, do a little bit of a experiment. Like you're going to be the detective on the job and try to, at 3 o'clock when the laundry closes down today, we're going to drop it down to 80 psi, see if it works, without problems. Then you keep dropping it down, and you make it down to 50 and say, oh my God, it's going crazy. We're getting carryover. So you say, okay, we're going to drop it to 60 psi instead of 50, and we can live with the boiler the way it operates. Chase, that'd be the way I would do it. It's time consuming, but you're getting the best actual response from your boiler then.
Okay, yeah, just trial and error. Yeah, that's kind of the approach that makes sense to me, and it does make it difficult sometimes when you need to try to quantify the potential savings, but you don't really know how far you can turn it down until you try it. But yeah, thanks for that.
Welcome. Now, what's weird is the higher the steam pressure, the smaller the volume. It goes against everything we said. So it's 2 psi steam, the volume of it is almost 24 cubic feet. At 100 psi, it's almost 4 cubic feet. So what happens, the higher the pressure you have, the more steam you have to push into that pipe to fill the pipe up. So the lower the pressure you can run that at, the less steam you need to fill your pipes and get to your process. How many elbows can you fit? I love this. Backrack gave me this picture, and it came from one of their books, and it came from an actual Polaroid, so it's not really that good. The guy used 1390s to put this in there. And then he was so proud of it that he made it sure it was hung up in there and kept this way. So yeah, if you see something like this, hey, there's a problem on here. We're getting close to the edge. Oh my gosh, I'm close to the end. Draft affects steam. I got called as a consultant. They were in Wisconsin. They were having all kinds of problems with a boiler, and it was going off on low water, and it was tripping all the time, and they couldn't. There was a lawsuit pending, and so they brought me out as an expert witness. And when I looked at the draft gauge, it read 0.5 inches water column. And so I said to the owner, I said, well, it's supposed to be 0.05 inches water column. He said, what's the difference? I said, well, one is 10 times more than the other. So what was happening with it at 0.5, it was pulling the flames into the boiler and actually going up into the stack. So what we found out was the barometric damper was too small. They had a 20-inch stack on here, flue pipe, and they were running an 8-inch barometric damper on there. Once they put the 20-inch barometric damper on here, the draft dropped on, and the boiler level just settled right on. It was great. So draft will really affect the steam in your system. Now, I wanted to show you this just to show you how a chimney affects draft. This was kind of interesting, and then we can stop for questions whenever you want. Yeah, I don't have a life. I watch this stuff. That's what a chimney does. It pulls your flue gases through your boiler and up the stack. Well, anyway, oh, what happened? I don't know. Did I do that?
Yeah, I
Was
think
it?
so. It's still we're still seeing your screen, so I think you just have to pull it back up.
I don't know what happened there. Let me find out. Okay, let me see why it's doing what it's doing. I'm not sure why it's doing that. Let me get it back online again. I'm sorry.
No problem.
Never had that happen before. Here we are. Okay, everybody can see that.
Yeah. Oh,
Okay.
good.
One one of the things that I see is you never want to have both of your pressure controls on one pigtail. This is the pigtail here. Because if this pigtail, its whole goal in life is to plug, and it does it very, very well. So what happens is once this thing plugs, you've lost control of your boiler. So what I recommend is I like to see the steam boiler controls on two different tappings in here. Just like this one, instead of the pigtail, they're using a water seal, which you're starting to see more and more of the people going to. Uh, but one pressure controls on one, and two of the other ones are on, or two are on this one, and two are on this side. So if this thing were to plug by any chance, you're going to still have a control on this side. If all four were on here and this thing plugged, you've lost control of your boiler. We're about 12 minutes till. Chase, did you want me to stop and take questions or keep going till
You know,
noon?
Ray, I think you got a lot of good content left. I do think we're going to go over. I think what I would like to do is continue and we'll just go over and finish the presentation. It is recorded. We can post a recording online for anybody that, and we will post a recording online for anybody that needs to drop off. You can still get your PDA certificate if you need to drop off. But I think we should finish the presentation because I don't want to miss out on the good content that's still
Okay.
there. So,
Okay.
and
Well, you're
everyone feel
okay.
free if
I'll
you are
talk
going to
all day
drop
on
off.
boilers.
Yeah, and if you are going to drop off and you want to get a question in, go ahead and do that, and I'll interrupt Ray as we go. Um,
Now,
somebody just
what?
asked Ray, which safety regulation do you follow in the U.S.? We have Indian Boiler Regulation IBR 1950 in India.
Oh my God,
Hmm.
we have so many.
Yeah,
It's ASME. We have it depends where you're located. Um, we have so many different codes that you have to follow, and so it just it depends on your location, and they go by the versions too. Like some states will have the latest version, some states will have versions from 6 or 8 years ago. So it's really hard to say. I hope I didn't mean to evade your question, but we it is tough.
yeah, and then there's also like insurance standards, and there's different codes within the codes for different pressure levels. So yeah, it's not that easy to just say one specific code.
Right. Um, what I wanted to, I wonder if there's anyone from Honeywell here. Honeywell, I love them to death, but they do stuff just to mess with people. And so what they'll do is if you're looking at your pressure control, the two of these here, the one on the left with the mercury bulb is a subtractive type of pressure control, and the one on the right is what's called an additive. And it really confuses people when you're going out there. What this subtractive one does is you set the pressure for whatever pressure you want. And that's where the boiler will shut off. So if we have this set for 5 and we move this up and we set this for 5, the boiler will shut off in 5. And then it goes by your differential on this side. So say we have this set for 5 and this one's set for 2. That means your boiler on a call for heat will operate between 2 and 5 psi. Well, here's 5 on this side, sorry. So it'll operate between 2 and 5 psi. This one is what's called a cut-in type. This is where the boiler starts. So we will set this for where the boiler starts, and we want it to start at 2 psi, and then inside there's a differential adjustment on a little white knob, and you set it for that way. So, when you're looking at it and you say, well, okay, how do I set my pressure? You have to ask, is it subtractive or different or additive? Here's what I talked about where Cambraco says, under no circumstances should this be margin be less than 5 psi. So if this is a 15 psi relief valve, they don't want you running your boiler higher than 10 psi. If you banging pipes, this was we see this a lot where they'll put in zone valves, and we kind of got rid of it when you're seeing a lot of steam systems go, but we still see this on breweries and other items. So what happens if you look at this system, they were having all kinds of banging. And like I said, you already know the problem, you just didn't know you knew it. So what happens is when this valve shuts down here, the Honeywell on the right, all that condensate that's up in here, all the steam condenses and lays against this valve, right? So now when this valve opens up the next time they have a call for heat, what happens to all that condensate? It goes flying up here at 60 or 50 miles an hour and hits the nearest fitting. So if you have valves like this, you have to be able to drain this down and trap this on here so you don't have steam laying against the seat of this valve. Same with this one. See, the steam drops down and just lays against that valve. Uh, it depends which way you want which way it's pitching. If it's pitching to the right, like this one is here, you want to be able to trap this side. If it's pitching back to the left, you want to trap this side. So you want to trap it where you're going to have the water laying against the seat. A lot of times, like we'll see guys that will say, okay, I'm going to trap this header, and maybe it's a 6 or 12-inch header, and I only need a 3/4-inch trap. And the guys will say, well, I'm just going to run 3/4 inch down on here. I don't need this. But you do, because what happens is steam is zooming through here, past here at 50 or 60 miles an hour. It's going to pull this condensate right up into here and pull it along, so it won't be vented out through the trap. When you have it at the same pipe diameter here, what happens that water drops down, there's no way the velocity is going to pull it out like a Venturi effect. How to turn your pipe boiler feed into a bomb. These boiler feed tanks and condensate tank, this one blew apart. You can see it was relatively new. And the reason why is because all the vents were plugged on it. This one here has the vent plugged on it too. They're lucky they didn't have it blow up, so these things have to be vented to the air. This guy made a homemade boiler feed tank on this one. I loved it. He got an old 55-gallon drum, and he put the water makeup on here. This one used this as a condensate tank. He used a plastic garbage or plastic bucket, and here's the pump down here. And that's what he used because his condensate tank went bad.
Looks like he's got a rain. That funnel is like a rain collector or something.
Yeah, exactly. One of the most confusing things is people will say, what's carryover? And a metaphor that I use for carryover is let's say you're out camping and you're making s'mores and you have your marshmallows over the fire and you're getting ready to put them on between a piece of chocolate and a graham cracker. And some jerk comes running over and throws water on your fire and then laughs about it. That's what carryover does. It takes all the energy out of the steam and causes it to condense a lot quicker than what it's supposed to. And one of the things you can do to look for carryover is look at the top of your gauge glass here. If you see all kinds of water coming over the top and dripping down here, it's telling you you have carryover and you should check it with the chemical treatment company. What is carryover? This was done by Wal McLean, and all this water up here is all carryover. And I'm going to show you what this thing does. You could see it all coming up over here. That's carryover. And this boiler is piped the way it's supposed to be. It's got a 24-inch riser above here, and on this particular one, they had one boiler pipe like this and the other boiler pipe like this. Why did they use the extra fittings on here? Well, what this does is this is a swing joint. When steam piping is connected to a cast iron boiler, they expand at different rates, right? So what happened on this particular one was the steam piping expanded at a greater rate than the cast iron section did. So what it did was it pulled it all apart here and they started having leaks everywhere. Whereas this swing joint, it allows it to go back and forth and absorb some of the expansion and contraction. Pipes
Hey
should be
Ray,
insulated.
I'll stop you for just a second. I know we're
Yeah,
bumping up on the hour here, and again, I just want to say we're going to keep going with this. We probably got about 15 minutes left, I would guess, just based on the number of slides. But if anybody needs to drop off, this will be available online, and so you can finish the presentation then. Otherwise, we're happy to have you if you want to stick around. But thank you everybody for joining. For those who do have to drop off, we thank you for joining. We also are going to have invites for our next webinar in January out soon, so keep an eye out for those. But yeah, we're going to keep it rolling here. So sorry
thanks
about that, Ray.
everybody
Thanks.
thanks everybody for coming. Steam pipes need to be insulated. A bare steam pipe loses 5 times more heat than an insulated one. And you're like, well, that just makes a room warm. Well, what it does, it causes your steam to condense, and it's this ripple effect. It's like pushing a snowball down a hill. It turns into an avalanche after a while, and you get to the point where this thing will actually uh, cause steam stall, and you won't be able to get your steam to flow through here. An uninsulated pipe produces 600% more condensate than an insulated pipe. So it could overload the steam trap. Now, what also happens is that this steam trap was sized for an insulated steam pipe, and now it's not. If someone pulled the insulation off or if they repaired a leak, now this is undersized for the load. Steam doesn't care about your flow arrows. I know you hate to hear that, but if steam's going this way and it's air's over here, it's going to go from low to high, no matter which way. So say it starts to condense over here and it starts to pull into a vacuum. The arrows say it's supposed to go to the right, but it's actually going to go shooting back to the left. Pressure goes from high to low. On this one, we have an insulated tank, and this one is non-insulated. So the steam flow is supposed to go this way. Well, if this is non-insulated, it's going to condense more. Your steam is actually going to come back this way quicker. It goes backwards. Steam systems need to breathe. And that's why we saw that boiler feed tank or the condensate tank that exploded and it turned it into a bomb. When you look at a steam system, when it's cold, it's filled with air. Most of it, 90% of it's filled with air. The only thing that has water is the boiler and maybe the water line in the condensate tank. So as we start to heat this up and it turns to steam, steam two gases can't occupy the same space. So the steam forms, it's a higher pressure than air, so it starts to push it out. And it goes up through the radiator, out the steam trap, and out the valve. So it pushes all the air out of here. So now when this thing is hot, it's all filled with steam. There's no air inside here, hardly any air. So when it shuts off, all that steam condenses. Remember, it said that it was expanded at 1,600 times its volume. So now it will condense and drop down to 1/1600th of the space it occupied. So what's going to take the place of it? Air comes rushing back in and fills up the piping. So this thing is doing it all the time, back and forth. And essentially, it's like breathing, is what I use as a metaphor. Like I said, two gases can't occupy the same space. If there's air in a radiator or in a pipe or in a piece of equipment, I can't get steam in there. It won't leave. And one of the things that's a little bit confusing about air is the warmer the air, the greater the volume. But with steam, the higher the pressure and temperature, the smaller the volume. So it likes to mess with your head a little bit. We want to get air out of a system, out of a steam system. Just to give you an idea, you have a 1/25th of an inch air column, air curtain of air inside there. That has the same R value as a 4-foot thick wall of iron. So it does great insulation. That's why they put it between the window panes. The problem and the solution are rarely in the same room. We had a problem in this particular classroom on this school, and we found the solution down in the basement, down in here. What happens is when the condensate was coming down, it went down into the system, and one of the hangers fell off. They removed the asbestos down there, and it was sagging, so the air couldn't get out. Once we lifted that pipe up and put it back in the hanger, it ended up working just like it was supposed to. Let me. One of the things that we see is people will put the steam strainers straight down. You don't want to do this because water can gather in here, and when steam comes through, it can cause condensate-induced water hammer and bang on the side of it. It should be vented sideways, like the top one over here, and only vented down. The outlet of it is vented down when you're working on liquids. What does a steam trap do? It vents air and non-condensables, but more importantly, it allows the system to breathe. So it vents air out when it's steaming, and it allows air back in when the steam is condensing. Traps are workhorses. How long will they last? Well, a trap opens and closes about 360,000 times per heating season, or over 1 million cycles in 3 years. This is based upon 4,000 heating hours, which I have in my area. So, I see people that have them 20, 30 years old. A lot of times the new ones aren't going to last nearly that long. So most of the experts say the thermostatic element, which is here, this is what allows the air out. They last about 3 seasons, and the float lasts about 6 years. Steam traps should never be sized for the steam pipe. Let's say we're going to have a steam pipe going on, and it's going to the end of our building, and it's 800,000 BTU with 640,000 BTU out. We're trying to maintain about 40 feet per second in the velocity. Anything over that, we could start getting carryover. So what that's telling me is we're going to need a 6-inch pipe on here. Well, what size should our steam trap be? If you look at the Spirax Sarco, a FT15, I can vent this 6-inch pipe. I can get the trap to 6-inch pipe with a 3/4-inch trap. It'll give me 650,000 BTU pounds of condensate, and that's what this thing is throwing out. More than that, So the higher the differential pressure between the inlet and the outlet of the trap, the higher the capacity of that trap. One of the things we see is if you have 15 psi on the inlet of the trap and 15 on the outlet, is this thing going to move much condensate? No, hardly any at all. And how would I get 15 psi on the outlet? Let's say the steam trap is bad on the next item down or the next room down. It's leaking steam into here. It could pressurize this condensate line. So you go in here thinking, oh my gosh, we got to change this trap out or we got to change this valve out or something. And every time you do it, it doesn't do any good. It's because the steam trap is failing on the other one. So when I talked about the solution and the problem are rarely in the same room, this is what I meant by that. Can we share steam traps? Well, you think, well, these are going to be expensive, a couple $100. I can just put both of them on here. Well, you can do that, but you don't want to. And the reason why is because if this thing is blowing steam through here and this one has a lot of condensate, it's going to be throwing that condensate back up into here and banging on the tubes and destroying it. Each steam consuming piece of equipment has to have a steam trap. So I would need one here and here. 1 psi will lift condensate 2 feet. So steam will actually lift your condensate up. Like say we have 2 pounds of pressure here, it will lift that water up about 4 feet. But to do that, we need to, this is going to cause a little bit of a seal. So we have to have an air vent on here. So we want to get the air in and out of the system. We want a check valve on the outlet, and then we'll let the steam trap do it. And this works fine unless you have a modulating valve on the inlet. Once you put a modulating valve, you can't lift condensate anymore because as this thing's starting to close down, you don't have the steam pressure to lift that. So now as it's starting to close down, all that condensate is going to be stuck in here. Next time this valve opens up, it's going to push all that condensate up and it's going to sound like a Blue Man concert. You're going to be having banging like you haven't heard in a long time.
Hey, Ray, can I
Yeah,
add a couple comments there?
certainly.
So as I mentioned, we approach these systems looking for efficiency improvements. And for those of you that don't know, steam traps are kind of the LED lights, if you will, of the steam system. They're designed to fail open so that you're still rejecting condensate from the system when they do fail. And at that point, they're just basically an open hole and you're just losing steam. So maintaining and testing and maintaining those traps is almost always a good opportunity unless it's just been recently done. And also, shameless plug here, we do have another webinar that focuses completely on steam traps and the economics of that. Also, Ray, I have a question here. Do you have a good reference for heating hours based on region or location? So like if you're evaluating a heating system, how many operating hours based on region or location?
There's the NOAA has a weather. It'll tell you the degree days, and that's typically what I go by. Or you can look on the weather bureaus for your location. A lot of times they'll have a listing of how many hours are below, where you're actually going to need heat. You can base it on degree days. Degree day is anytime the temperature is below 65 degrees. But what you have to do is you have to factor out, if it's going to be in the spring or summer or early fall where you don't actually have the heat on, it'll give you a false reading. So what I will typically do, I'll go from October 15th to maybe March 15th, and I'll look at the degree days in that time. I hope that answered your question.
Yeah, I think so. And a lot of people on the call, I'm sure, are familiar with heating degree days and cooling degree days, but that's how I would typically approach it as well. Just look up the heating degree days for that region, and those vary year by year. So like when we implement efficiency projects, we'll have to go back, look at fuel bills, establish a baseline, and then for the new year, it may be a colder or warmer year, and then you're going to use an adjusted baseline to compare savings. But yeah, yep. Thanks, Ray.
Okay. And this is my last slide, and this is something to think about, that uh, heat goes from hot to cool. So if its steam is up here, what it wants to do is it wants to get down into the condensate and cool off. That's all it wants to do. So let's say you're walking through a grocery store and you pass the aisle with all the refrigerated goods, milk and creamers and stuff, and you think, "Oh my God, that's cold." Well, what it is, it's not cold. It's taking the heat from you and going into that case. So a lot of times we forget about that. And so if I have steam in this pipe and I have a lot of condensate in here, it's going to cause this to condense a lot quicker. That's why we want to get rid of this condensate that accumulates in the pipe. So anyway, I guess that's it. If you need to contact me, you can email me or you can look at Boiler Room Detective. Um, if there's anything, I thank you for your time and your patience, and I hope I answered some questions. This is a 4.5 hour class I put into 53 minutes, so we'll see. So.
No, this is great, Ray. We really appreciate it. We do apologize everybody for going over, but we did want to capture all of it since it will be it's been recorded and it can be available for people at their leisure. I want to personally recommend Ray's books. I have probably most of them, at least the ones that pertain to steam systems. They're very easy to read. He has a lot of good checklists and visuals, and they're very well put together. So for anybody who's looking to learn more and just kind of wants an easy read with practical knowledge, I would certainly recommend Ray's books, as well as his Boiler Room Detective series. Just short little videos. I watch most of them. I think you put out like one a week, and it's usually like 5 minutes, so it's easy to watch and a lot of interesting info in there. Also, I want to remind you, if you want a PDA certificate, you just email me at cbean@steammgt.com, and we will send that to you. We have a note cut off there on the bottom. That is that our next webinar is on modernizing hot water systems, so retrofitting conventional hydronic heating with condensing boilers, which we're seeing a lot of nowadays. So that's going to be on Thursday, January 9th, and Ashley has put a link to that. So you can go ahead and register right from that link in the chat now. So please do that, and we look forward to seeing you on that webinar. We thank you all for attending, and especially thank Ray for presenting today. It was a wonderful presentation, and we encourage you all to go check out his stuff. And with that, and Ray, unless you have anything else, that
Nope.
concludes our webinar.
Thank you very much. Appreciate you, everybody.
All right, thanks everyone. Bye-bye.